7 significant decimal places. That's very interesting because I believe it was the second time I had come here and I had some questions because I was computing something for the Bohr nuclear magneton. And I'm like, okay, that's really cool. Like, it seemed to deviate. The interesting thing was the actual number for what we were looking for deviated as well. So I'm like, I need to ask that about this. So I asked that about this. And then we found they had updated some of the measurements. Because apparently back in, I believe, 2018, 2019, they started to actually redefine SI to try to get things more aligned. So I think either H or H bar, they went from like 12 significant digits, and then they reduced it to 10. Why? Now, I don't know any of these really smart scientists or anything, but I tend to assume that if you're trying to have a coherent system of units, you want them to be as tight to the best of our measurements at the time. That makes sense. It's the whole point of the metric system, utilizing a coherent system of units. Why is this important? Well, something that I learned from Thad was you have certain arrangements. So if you have force equals mass times acceleration. Okay. Mass is mass, acceleration is length per time over time squared. Cool. Then we have energy equals force, and then that's, I believe it's times distance. Okay. Okay, so you have force times distance. I'm like, that's cool. And then you have power, which equals energy divided by time. I'm like, okay, those were, is it Newton? I think it was Newton, no, Newton Maxwell. It was, I just remember, or at least according to Wikipedia, if you can set up something utilizing these units, it's a coherent system. Groovy. For my 5 individual units, we can get that. Just for notation's sake, what are our 5 ingredients? We have time, we get space, which is length, we got charge, we got mass, my messy handwriting, and then we have temperature. As I totally probably misspelled that because I have been absolutely, spelling was always my worst subject, that and penmanship. But yeah, spell check has ruined me. But I don't know about any of you, but it's like, okay, we have these ingredients. We have the ability to connect these. I'm like, okay, do I know what that all means? No. But from these dimensions, which very often I believe in, and again, I'm not a professionally trained physicist or a mathematician. I'm just a dude that had a lot of questions, used science as my safe space, and was blessed enough to have the opportunity to actually be here in front of you all today. Thank you for that. But it's very interesting what you can construct, because very often we'll label things like the speed of light is 1, gravity is 1. It's like, all right, that's cool. But at the same time, it's like, sometimes you do need the numbers, or at least don't worry about the numbers, just realize this is utilizing a unit of time, this is utilizing a unit of space. So it's like, all right, we have mass, acceleration, all right. It's a change of length, and to time, boom. So you can just basically start to fill it in there. And one of the things we're looking to do with the website and everything, which hopefully should be up by the beginning of the year, you'll basically just be able to go in and just start to visualize, because it's like, if you spend a lot of time looking at these things, yes, you'll start to develop intuitions. If you spend far too much time like myself on Wolfram Alpha, you'll start to see how these different things line up. And the ways they line up are absolutely fascinating. So we'll go with green. So one of the interesting things as I digress back to 7 significant digits, we have Planck length, Planck mass over the Planck charge, and that's squared. Length, mass, charge squared. What does that equal? Well, to be fair, it's approximately 10 to the negative 7. Coincidentally, at 7 decimal places, that's where that starts to get wonky. Interesting. Look for some connections. Not going to be bold enough to claim something yet, but interesting potential connections there. But that's very interesting, and I'm not saying that's one of the reasons why CoData was updated a little bit early, and we're still waiting on the 2022 release, I believe, or 2023. But why? What might be going on there? I don't know exactly what's going on, but it seems to be a clue that maybe something very interesting is happening here. Oh, this also approximately equals 1 ampere constant. Now you want to make sure you have the constant there, because I've thrown an ampere before, and then that gives you a completely this is one of the things that you learn, and this was one of the things that when I was just initially, I saw some of this stuff and I started to investigate myself, it would throw me off, and I don't want to have to be just private messaging Thad like every 5 minutes. How do I do this? How do I do this? No, you would go to the monastery to do that. So yes, I'm can be that anal. But one of the interesting things is like, oh, this appears to be some form of measured stuff that's doing a particular thing. What's it doing? I might clip into the point where I did some of my previous videos on this, because when you start having interesting things and you start multiplying, I believe, the inversion of this by the speed of light, and I might be getting this wrong because this is just off the cuff. I believe this actually comes out to the Planck impedance. What the heck is that? It's approximately 29.92 ohms, which was very interesting because I literally didn't realize till the other day. I'm like, wait a second. If I take that and multiply it by that, I'm like, wait a second. It basically comes out, the dimensions literally cancel out, and you end up getting this or that or this or that. Now, I might be getting those wrong, the exact construction, but I'm like, this is a very interesting thing. I literally didn't notice until last week. And then my brain fixated upon that because it's a very interesting connection. It's like, I had no idea. They say that, okay, we can get energy for mass, and we can turn mass into energy, or excuse me, we can turn energy into mass. Apparently, experimentally, we've actually managed to create some mass from energy. Fantastic. Do we know how we did it? I don't know. Might this be maybe a clue? Maybe. I'm just following some of the math, and again, plug this into Wolfram Alpha. Is it wrong? Maybe it is. Seems like a pretty good source to me. Again, totally biased, friend of the show. But what's also interesting is you look at some of the connections, some of the symmetry that we have with these different geometric actions, let's say, because geometry has always been a big thing. I mean, I started to learn the concepts back in the day, and it's like, well, you need to learn this because you learn this. I remember the Pythagorean theorem. It's like, okay, you can have your triangle here, triangle. I mean, who doesn't like triangles? I like triangles. All right, so you have A and B and C, and then A squared plus B squared equals C squared. So then you take the square root and you can figure out what that is. I'm like, cool. I never knew when the heck I would need to use it. I mean, to be fair, I didn't expect to be at a place called the Physics Monastery when I was 39 years old, but hey, life throws you curveballs. Sometimes you actually hit them, or if not, hey, make some lemonade. Combine whatever analogy you want there.